Hello, good evening, everyone. This is Dr. Bhupender. I am an associate professor in the Department of Computer Science and Engineering, Purnima University, Jaipur. From today onward, we are going to start a course on Linux. The name of this course will be Linux and Shell Script. So, this course will be containing 5 units. So, in this series, we might be having 40 lectures. So, in these 40 lectures, we are going to cover this whole syllabus. So this, as I said, this whole course is divided into 5 units. So here, from today onward, we will be discussing, or maybe this lecture is starting with unit first. So today's agenda of talk is like this. First, I will be discussing about the brief history of Linux, how Linux has evolved since 1991, and then we will be delving deep into the architecture of Linux, and of course, we will be talking about the future of Linux, how Linux is a robust platform, how Linux is secure and all. So if time will permit us in this lecture, yes, we will be discussing about some Linux commands also, like man command, echo command, printf, so on and so forth. So before starting this course, I assume that each and every one of you have installed Linux on your system. Maybe you can install this Linux operating system on your VM workstation or maybe on VirtualBox. So I assume that you might be having this Linux operating system as a standalone machine, or maybe you're using these virtual machine. So that thing I assume. Okay. So let's start with today's lecture. So first we will be discussing about the brief history of Linux. Each and every one of new each and every one of us know that in initial days computer was as big as a room, or maybe as big as houses or as big as parks. So can you imagine how difficult it would have been to handle them? Moreover, each and every computer would have been running on different operating system, and for each and every computer they have written different operating system and different application software as well. So in those days it was very expensive for normal people to afford an operating system or maybe a computer or something like that. Okay, so with this knowledge, let's delve deeper into the history, architecture, and future of Linux. So, if we talk about the history of Linux, so first we have to talk about the birth of Linux. So, in this 1991, a person or a computer science student, we can say, a computer science student whose name was Linus Torvald. He was a student at the University of Helsinki in Finland. He began developing a free and open source operating system kernel as a hobby project. Okay, it was his hobby to develop something based on Unix. So basically, he was inspired by the Minix operating system. What was the Minix? Minix was a small Unix-like system developed for educational purpose only, but it was not open source. So this Linus Torvald, he aimed to create a system that took advantage of and the capability of Intel 80386 processors. Okay, so on August 25th, 1991, Linus Torvald announced his project on the Usenet news group, and he made the first version of Linux kernel, and he named this first version of Linux kernel as version 0.01. And he made this available to the public in September 1991. Okay, so further, if we consider the year from 1992 to 1993, so let's discuss. That was the period of open source and collaboration. Various peoples were collaborating on the developing of an operating system. So that was the period. So in 1992, Linux was relicensed under the GNU General Public License, which allowed everyone to freely use, modify, and distribute this software. So this change attracted a community of developers and enthusiasts who began contributing to this project. So by 1993, Linux had gained significant popularity or significant traction, leading to the creation of the first Linux distribution. Notably, early distribution include Slackware. That Slackware was created by Patrick Volkerdig, and the second was Debian, that was initiated by Ian Murdoch. So these provided pre-compiled binary package management and easier installation process. Next come the commercialization and growth stage of this Linux. This commercialization and growth stage of Linux was from 1994 to 1999. So in 1994, this Linux Torvald, it released Linux kernel version 1.0, marking a significant milestone. That was a significant milestone in the history of the Linux development. So this version was more stable and it included networking capability, and those networking capability made it much suitable for the server use. Now, the Linux operating system could be used for server. Yes, that was there. So throughout in the late 1990, various commercial distribution emerged, such as you might have heard Red Hat Linux, SUSE Linux, and Mondrake Linux. So various distribution have emerged throughout the late 1990s and 1991. So this adoption of Linux, this grew very rapidly, especially because Linux could be used as a server. So in the server market, Linux was very, very popular. It became popular among internet service provider also, web hosting companies also, and among all those organizations who were or which were seeking for cost effective, reliable, and secure server solution. Because Linux was that much popular for server. And if we consider from 2000 onward, if we consider from 2000 onward, so this Linux ecosystem was continuously growing. Linux kernel evolved and various features were added into it. Various modules were added into the Linux kernel, which improved the hardware support, scalability, and performance enhancement of the Linux operating system. So Linux, that's how expanded beyond the server. Now Linux was not only used for server, but it expanded beyond the server. It expanded beyond the server and it expanded into various domains like desktop computing, embedded system, mobile devices like Android, and cloud computing. So today, Linux is dominant force in the technology world of significant portion of the internet, data centers, supercomputers, and IoT devices. Yes, Linux is very, very popularly used in these domains. Okay, so yes, next we will discuss about the architecture of Linux. So this architecture of Linux, this comprises several layers. Each and every layer is having distinct functions and distinct responsibility. Different responsibility, different functions have been assigned to each and every layer. So you can see in this diagram, you can see in this diagram, application layer is there, shell is there, kernel is there, hardware is there, utility. Okay, so these are there. So yes, let's start with the hardware layer, the innermost layer. So this hardware layer includes the physical component of a computer, such as central processing unit, such as random access memory, such as SSDs, such as hard disk drive, such as all input and output device like keyboard, mouse, display, screen, and maybe network interface card, or everything which you can touch. Yes, all those things are included in the hardware layer. Perfect. I think that makes sense. And then you see the next layer comes. The name of that layer is the kernel layer. So what is kernel? Kernel is the core component of Linux operating system. This is the core software of the Linux system. It manages majority of tasks. Like it manages hardware resources. It provide essential services to higher level component. So key function of the kernel can include like this: kernel do process management, kernel do memory management, kernel manages the device drivers, kernel also manages the file system of the operating system of this Linux operating system. And yes, network management is also done by the kernel. So if we consider the process management, then how the process management is done by kernel? This is like this. The kernel schedules and manages all process so that each and every process gets sufficient CPU time, and it ensures that efficient CPU utilization is done. And yes, this also schedules the process for CPU. Yes, that is there. So that's how it manages the processes. Now, you might be thinking, what is process? The active program is called as process. We have discussed it so many times in our class. Okay. So next comes memory management. So how this kernel do memory management? The kernel allocates and deallocates memory. It handles virtual memory, and yes, it manages the security aspect of memory. Now, how memory can be protected. No two processes can simultaneously access the same memory. Yes, that is managed by the kernel. And then kernel also manages device drivers. So how the kernel interact with devices? So kernel interact with devices. Kernel kernel interact with devices through device drivers. Okay, so the kernel interacts with hardware devices through device drivers. These device drivers provide a standardized interface for assessing and controlling the hardware. Okay, so that's it. And yes, kernel also do file management. So see, in this slide, this kernel is mentioned. Kernel also do the file management. How? It handles file system operation. It handles all operations like reading the file, right? Like writing the file, like giving the security permission to files. And yes, it helps in organizing data on the storage devices. Yes, that's how it helps in file management system. The network management, yes, kernel manage network communication. It implement protocols. It handles data transmission and reception. Yes, that thing is done by the kernel. So if we go back to the previous slide, then comes system library. Okay, so the system library provides a set of functions and system calls that applications use to interact with the kernel. So these library abstract the complexity of hardware interaction and offers standardized APIs. Okay, and then comes system utility program. Okay, so this is the system utility layer. So this system utility includes various programs and tools that perform administrative tasks or that manages system resources, and those programs that provide essential services. Examples, yes, we can take various examples like shell program, bash is there, system monitor tools like in further lectures we will be studying about this top and htop. Yes, and package manager, yes, these system utility layer include all these. Package manager, yes, like yum, apt-get install and all, yes, apt-get update, we will be studying all these things in the lectures which are forthcoming. Okay, so yes, so all these things are included in the application layer. So basically now we can conclude that application layer contain user application and program that run on the operating system. These can range from command line tools to graphical applications and web browser. Yes, so all these things are there. Now hardware layer, yes, we have already discussed. Kernel, we have already discussed in detail. And yes, shell. What is shell? So shell is basically an interface between the kernel and the user. Okay. So this is the interface between the kernel and the user. Now, if you ask what is kernel, kernel is basically the interface between the operating system and the this basically interface between the shell and the hardware devices. Okay, so that's I think clear. And yes, whatever command you're going to type, all those commands will be interpreted by the shell. And yes, those commands will be interpreted by the shells, and shells will be sending the system calls to kernel, and that's how this uh, whole execution will takes place. So we can, classify this shell into two: graphical shell and the command line shell. So if you are executing some program by clicking on the icon, yes, that is the graphical shell. So if you are executing some program by typing the command, that comes under command line shells. So in this Linux, in the forthcoming lectures, we will be working in command line arguments only, command line shell only. Now comes the features of Linux. So features of Linux includes the portability. So portability, what do you understand by the portability? Portability means Linux is highly portable. It can run on wide range of hardware platform, including personal computers, ARM-based devices, mainframes, embedded systems, so on and so forth. So this Linux operating system can run on all these devices. So this portability is facilitated by the modularity and abstraction of hardware interaction. Okay, and then comes the open source. So Linux is released under GNU. GNU means General Public License. So that general public license allows user to freely use, modify, and distribute the source code of the Linux kernel. So this openness, this fosters collaboration, innovation, and community-driven development of the Linux operating system. So if see, you can download this Linux, the source code of this Linux operating system from online repositories, and you can modify this Linux operating system according to your uses, and you can redistribute this Linux kernel to others also. There is no restriction. So that's how we can say this is the open source. Now, multi-programming. Next comes multi-programming. You see this? So, yes, multiple programs can be run simultaneously on Linux operating system. Then comes multi-user. So, Linux operating system supports multiple users simultaneously with each user having individual account and permission. So, this feature is essential for shared environments such as servers and workstations. You might be working on servers and might be working on these workstations, and these servers and workstation on those things, they would have there will be multiple users. Yes, so each and every user will be having different permission, will be having different individual accounts. That's how this Linux operating system supports multiple users. I think that's okay. And then yes, multitasking. Linux is a multitasking operating system. It is capable of running multiple processes simultaneously, concurrently. Okay, so the kernel efficiently manages CPU resources by doing this multitasking, and each and every task is smoothly executed. I think that's clear. And then Linux is having a file system. The name of that file system is hierarchical file system. Means there would be one directory. In that root directory, there are various other directories, and then subdirectories, and then subdirectories, and inside those subdirectory or maybe subdirectory you can have your files. So that is the tree like structure of arranging the files in the system exist in this Linux operating system exist. So that is the hierarchical file system. This is also a feature of Linux operating system. Then comes the security aspect of the Linux. So this is the most secure, robust security features are there in Linux. How that can be explained? Because you will be studying in the forthcoming lecture, Linux supports various users and various group permissions. So Linux uses a permission model to control access to files and directory based on user and group ownership. So that's how this Linux is secure. And Linux doesn't give execution permission to a file by default. So that is also a security feature. We will be studying this in later chapters, in later sessions. Yes. So Linux includes firewall capability also through tools like iptable, nftables. So these are inbuilt tools in the Linux. We will be studying about iptables and nftables and all. So by using this iptable, the administrator can restrict the access. Okay, access restrict the access of the user to the net to the resources of the server, or maybe resources of the that particular system on which this Linux operating system has been installed. So yes, various enforcement, yes, means various security policies can be enforced. and can be defined by the administrator. That's why this Linux operating system is very much secure. Linux also support encryption. So Linux support encryption of data protection, including disk encryption. Okay, and encrypted network communication can also be achieved using Linux operating system, such as SSL, TLS. Yes, that will be studied. Shell we have already described about the shell. Okay, we can again discuss some more features like stability and reliability. So Linux is very well known for its stability and reliability, often running for extended periods, months, or even years without crashing or requiring a reboot. Windows system may crash, may require reboot. It may not run for maybe for months or for maybe years, but yes, Linux machines they can run for years also without requiring a reboot. Okay, so this makes it a preferred choice for critical system and servers. A server has to, on for all time 24 into 7 into 365 into whatever. Okay, so this is the preferred choice for the people who are working in the critical domain, working in the domain which is using critical these systems, and yes, which are using the servers. Yes, that is there. So further, this customization can also be done in Linux. We have already discussed this phenomena. Okay, so now we will be discussing about the first command. Okay, so let's see. So you can see on your screen, we have a command, echo command. What is the name of that command? Echo command. So now, why echo command is used? So echo command in Linux is used to display line of text or strings. These line of text or the string that you have to pass as you have to pass as an argument with echo command. So you can see the syntax of echo command. Okay, you can see the syntax of this echo command. Perfect. So this is the syntax of this echo command. And yes, you can see various example. The first example, if you have to write echo, and in this double inverted comma, you have to write hello world. Once you press the enter, so this command has to be written on the terminal. Let me make it clear. These commands are to be entered on the terminal. Perfect. So if you type on the terminal on the command prompt echo and in inverted comma hello world and press enter, the hello world will be printed. Similarly, echo hello world and in between hello and world, if you type \n, then what will happen? This will insert new line between hello and world. Perfect. So these characters are also can be used while displaying the line of text and strings. So see, echo and then option. Yes, option can also be inserted between the command and the argument. We have to understand the basic syntax of the command in the Linux. So in Linux, this is the basic syntax. First, you have to write the command, then you have to write the options, and then you have to write the argument. So in this case, this is the command, this is the, see, this is the command, and this hyphen a, this is the option, and this is the argument. Sometimes you may not insert the argument and the options. Command is, yes, that is the necessary part, Why we insert options? We insert options so that we can change the default behavior of a command. So to change the default behavior of a command, we insert options. So all these options will be preceded by this hyphen, dash will be there. And they may be combined. See this, generally what happens, this option will be of one character only, but you can also see two options can also be combined together. Yes, that you will see once we will be working on the practical aspect of this Linux. Yes, that you will be seeing two option can also be included. Okay, so let's proceed further. So now comes this options. Okay, now comes this option. And see this, if you insert hyphen and in between the text, yes, this will create new line. New line from where this was used. If you insert hyphen B, what it will do? It will remove the spaces between the text. Perfect. Similarly, if you insert hyphen T in between the words, in between the strings, yes, it will insert the horizontal tab space between those words. So you have to take care that if you are doing this, you have to use option also, option E. Perfect. And see this last hyphen V. If you insert this hyphen V, what it will do? It will insert the vertical tab space between these words, moon, sun, and earth. So this moon, sun, and earth will be displayed vertically. Like first moon will be there, then sun, then earth. Okay, so that's how it's going to be. Okay, so next command. Now let's understand the next command, printf. So echo and printf both are somewhat similar. Yes, there are differences, but you might have seen the printf in C, isn't it? So you might have seen the printf in C. What the printf command does in C, it prints something on the screen. In our case, this printf command will also print something on the terminal window. Okay, the syntax of this command is like this. First, you have to write printf, then you have to write the format specifier, and then you have to write the argument. Okay, so now you can wonder and you may ask, what is the format specifier? So the format specifier, they are basically used to specify whether this argument is to be treated as a string, or this argument is to be treated as an integer, or this arguments are to be treated as floating point values. Yes, so that's how you use these format specifiers with the arguments. Perfect. So in this first example, if I use printf and then space, and then in the first inverted comma, this percent s, and then this is the new line, and then the second inverted comma like hello world. So this hello world, this whole thing will be treated as a string. In this case, in second case, this 213 and 109 will be treated as an integer. And in the last 1.32 and 3.14, these two values will be treated as floating points value. Okay, so I think that is perfect. Now we comes to now we come to discuss this path command. Path is basically not a command. This is an environment variable. This is basically a system defined variable. Okay. So what it does, so it instructs the Linux system in which directory to search for executables. So all the executable binaries are stored in this